Three, 1, 2, 3. I'm at ICFO in Barcelona, and I'm here with Professor Jens Biegert, who took me to this laboratory. Jens, where am I?
You're at the heart of ICFO. It's our temple, basically. So this is the lab of the Attoscience and Ultrafast Optics group.
And what am I looking at?
You're looking at some part of one setup for our ATTOSECOND soft X-ray beamline. So this is one of the highest energy TISAF lasers that we frequency convert. We use a lot of different techniques and tricks like filamentation to make short pulses. And so this is basically the motor behind our ATTOSECOND research.
Very often we talk to the industry of femtosecond lasers. They're getting lots of interest from the industry. This is an attosecond laboratory. For many years, attosecond science has been very fundamental, but you have applications for it, correct?
Yes, so I think one thing to realize is that attosecond science, for me, it's not the hunt for the shortest pulse or the highest intensity. It is really a technique that allows you to look at the fundamental interactions inside materials, inside substances like molecules. And if you have a way to see how they change over time, how you can influence them, you have really the master key to understanding many problems. So regarding applications, it's fundamental, but at the same time, if you understand why an organic solar cell is only 15% efficient, and you can see the mechanisms behind it, then you have a real chance for the first time to find an engineering approach to address this. Same in materials, same for optical computation and things like that. So there are many direct applications that come out.
For many years, we have seen non-destructive testing being very exciting as a field where terahertz entered, where other technologies have entered, hyperspectral imaging is coming. What needs to change for attosecond science to reach that market segment?
I think in attosecond science, we're actually at the verge. We and others have now shown the applications to materials, to chemical problems, for example. We just looked at what many people look at for a long time, which is how does a ring open, or a ring molecule? Why is it important? Because it needs to open to make polymers. This is the basis for chemical industry, for example. So this is actually, we are currently starting to see that. So it's actually a very exciting time.
Can we see the rest of the laboratory?
Of course we
can.
Let's go. Just follow me. Okay. So here is our attosecond beamline. Normally you expect to see something like this in a synchrotron or in an FEL, maybe bigger, maybe 10 times. But this is something where we can now, inside here, for example, directly look at materials, at molecules, at chemical reactions. This is where we do these experiments. Over there, if you follow me here, this is another technique that is related to it, which is a reaction microscope. So what this is basically, it's a camera that can look at one single molecule, and it zooms into the molecule, and it sees what makes a molecule, which means it sees its individual atoms, where they are in space, and how they change in time. So this is kind of like one of the ultimate movies of how you can see what a molecule is, how it behaves. And the really exciting thing is that we image the molecule with one of its own electrons. So it's kind of, we call it a molecular selfie.
What problem are we solving?
Here, the problems that we're solving is, this relates to chemistry, chemical industry, or physical chemistry. And what this is, for example, nobody has actually really seen a molecule by itself out of its atomic constituents. So again, it addresses the same issues. Chemical industry uses about 17% of the global energy budget. If you could just understand a chemical reaction and you reduce its energy consumption by a few percent, it would have already huge impact. So we're trying to look at this from a fundamental principle, but with direct applications.
As you know, I run an industry association at Optica, so I'm very interested in which lasers you use.
It's a good question. Actually, I want to tell you, we have many collaborations also with laser companies, because what we need is typically not off the shelf, but what we develop is interesting for the industry, so it feeds back directly. So we do not really have this separation between academia and industry. What do we need? Well, we try, from our experience, to look at the problem from the back. What do we need to address a certain problem? And then we actually draw from, we need pump lasers, we need fiber lasers. It goes into thulium fibers. We use photonic crystal fibers. We use special materials, coatings. So actually it's from the whole range that is available in the market. You see one example here, Jose. For example, this one is the laser oscillator, which nowadays we don't build anymore. So this is a commercial system. Then we design certain parts of it because we want specific parameters, but we integrate commercially available parts, the pump lasers, the seed laser, the diagnostics and so on, the cryogenic cooling. In this case, we built it because we just wanted different parameters that you cannot easily have commercially. So, for example, this is from Gitterwerk.
Yeah.
Right. This is, it's the husband of Ulrike.
Yeah, yes.
So this is one of the biggest transmission gratings ever made, and it allowed us to increase the efficiency, for example, of such a system from 65-70% to 95%.
They're all listening to you. The company is making femtosecond lasers. The company is making hollow core fiber, photonic crystal fiber. What would be your Santa Claus Christmas list? What would be that thing that you cannot find in the market and you would like them to give to you?
I think it all exists already. What we need is that they are open enough to try to listen, provide a little bit the extra thing that gives us the cutting edge, and that feeds back to them. So they actually have what we need already.
Is there a way that companies can provide you with some of the technology for you to try and test?
Yes, so for example, we're currently talking with one well-known laser manufacturer, and actually I met them at some meeting not so long ago, and it seems they were willing to give us the benefit of the doubt, and they will come in December with one of their cutting-edge systems, and we'll actually demo with them what can be done in attosecond science. So this is great for us, because we can try something that you normally cannot do easily. And for them, it provides a direct example of what it's useful for.
You're also the chair of the Optica Meetings Council. Is there any ATTOSECOND community? How does it work with the other centers that are also collaborating and working with ATTOSECOND? Do you talk to each other? Do you meet? Do you share knowledge, expertise?
Yeah, actually, so of course, we compete, but we also collaborate. And for example, there is one European network that I was also leading for some time, Laser Lab Europe. And there we provide, for example, access. So somebody from a company or researcher or from another group can come. We give access time to do joint experiments. This is what we like a lot in Europe, but they also do it in the US with LaserNet. So I think there are nice opportunities to work together. My interest is, and I think what is important in terms of meetings is that we look across the fence, that we work with people that are interested in material science, in devices, because we need to understand their problems, and they can then come and we can see if it's kind of matchmaking. It's like what you're doing all the time, right? I think this is exactly beneficial because attosecond science is coming out of its initial stages, and I'm excited by the opportunities for the applications with it. Yeah.
In Europe, for many years, we had LI, we have CERN. Is there any like geographical constraint, like any region in which you need to be close to get part of the governmental national European funding?
No. So even the Laser Lab funding, the EU, allowed up to 20% to be given to non-Europeans. So if you're from China, if you're from New Zealand, if you're from the US, you can come.
When do you think we're going to have the first product commercially available based on attosecond science?
Well, it depends what you mean exactly. So, for example,
something that you change of money and then you get it.
Yeah. So, for example, the mid-IR developments that we had pioneered is a product that, for example, Thales is making out of it. So that's a system, a laser system mid-IR, which is just a driver, part of the beamline.
Yes, it was really great to be at ICFO.
Nice for having you.
Nice laboratory to see. Finally, I saw your attosecond science lab. Until the next time, this was Jose Porto and Jens Biegert from Optica at ICFO. That was awesome.
Thanks for coming.